Walk into any Class 11 math exam, and you will see students sweating over abstract formulas they half remember, trying to force word problems into equations that don't fit. They struggle because they are trying to memorize counting rather than visualizing it. Permutations and combinations, or PNC, operates as a strict logical decision-making process. To solve any counting problem, you only need to ask one filtering question. Does the order matter? Think of a digital locker. If the combination is 1, 2, 3, and you enter those same numbers backward as 3, 2, 1, the door stays locked. The sequence dictates the outcome. In math, we call this a permutation. The P stands for position, because the specific arrangement matters. Now compare that to making a fruit smoothie. You drop in an apple, then a banana, or you drop in the banana, then the apple. The blender runs, and you get the exact same drink. The order is irrelevant. This is a combination. The C stands for collection. Correctly identifying your problem as a strict password or a mixed smoothie is the singular decision that determines the mathematical path forward. Let's follow the password branch of our logic tree first, where order is strictly enforced. Instead of reaching for the NPR formula, we can use a more intuitive, visual approach, the slot method. Imagine you have 3 friends and 3 available chairs to sit them in. You need to know how many specific seating arrangements are possible. Look at these 3 red slots. For the first chair, you have 3 choices of who to sit down. Once that person is seated, the available options shrink, which leaves you with 2 choices for the second chair and exactly 1 choice for the last. Multiply those choices together and you get 6 unique arrangements. That is all a permutation actually is. A cascading sequence of multiplication that continues until you run out of available spots. But what happens when we switch over to the Smoothie branch, where the sequence of choices doesn't matter at all? To calculate a combination, we start with a permutation and then mathematically erase the redundant arrangements. To get our blue NCR combination formula, we add a denominator, r factorial. If you pick 3 items, they can be shuffled in 3 factorial, or 6 different ways. Since those 6 sequences result in the exact same smoothie, dividing by r factorial strips those redundant counts away. You can test this in the real world with the handshake trick. If 10 people meet in a room and everyone shakes hands, how many handshakes happen? Calculating 10 factorial assumes the order matters, that person A shaking person B's hand is different from B shaking A's. But look at these dots. Reversing the direction doesn't create a second handshake. They are already connected. To find the unique pairs, we use 10C2 to divide out those reverse interactions. Mathematical division is the required tool for erasing the concept of order from the board. Passwords and smoothies handle a single group of items, but often you have to make multiple distinct choices that stack on top of one another. This brings us to the second layer of our decision tree, the fundamental principle of counting, also known as the and/or rule. Whenever a problem requires you to fulfill one condition and another condition, you multiply. If you are packing a suitcase and need to pack a shirt and pants, and you own 3 shirts and 4 pairs of pants, you multiply 3 by 4 to get 12 possible outfits. As this layout shows, the rule changes if your options are mutually exclusive. If the dress code says you can wear a shirt or a dress, you simply add the options together. 3 shirts plus 2 dresses equals 5 total choices. The word and expands your possibilities exponentially, while the word or simply adds alternative paths. This flowchart is the complete operating system for counting. First, you hit the order filter to define your branch, red P or blue C. Then you hit the and/or filter to decide if you are multiplying or adding. Run any intimidating math problem through this sequence, and the anxiety of guessing disappears. The formulas NPR and NCR sit at the finish line of each path. You don't need to guess which one to use. The branching logic points directly to the correct computation. Now, put this framework to the test. You have 5 books on your desk, and you need to pick 3 to pack in your bag for a trip. Run it through the tree. Does the order you put them in the bag matter? Decide if this requires a P or a C. Calculate the answer and drop it in the comments. Mastering the art of counting means recognizing that human logic always precedes mathematical computation. Combinatorics is the skill of calculating vast possibilities without having to list every one by hand. Success in Class 11 math depends on a specific decision made before you ever write down a formula. Does the order of the items change the result? On the left, making friend A president and friend B secretary is different than the reverse. But on the right, those same two friends are moving a sofa. If they swap sides, the group remains identical. The calculation shifts based on this distinction. Distinguishing between an arrangement and a grouping determines every step of the problem-solving process. When order dictates the outcome, we use a permutation. You can link the P in permutation directly to the word position. A digital locker shows why position matters. If your code is 1, 2, 3, entering that specific sequence opens the door. Using the same digits as 3, 2, 1 keeps the mechanism locked. The numbers are the same, but the position change creates a failure. Any scenario where a different sequence creates a unique outcome is a permutation problem. That dictates which set of rules we apply. The traditional NPR formula often causes confusion. Staring at factorials stacked in a fraction looks intimidating. We can bypass that notation by using the slot method instead. Imagine placing 3 people into 3 chairs. For that first seat, you have 3 choices. But once that person sits down, they are no longer in the pool. For the next chair, you only have 2 choices remaining. That leaves just one final choice for the last spot. Because you must fill chair 1 and chair 2 and chair 3, the AND rule of counting requires multiplication. 3 times 2 times 1 gives you 6 possible arrangements. Breaking a formula down into the physical act of filling slots makes the math easier to visualize. Let's increase the difficulty. You have 5 people, but only 3 chairs. Mentally construct your slots. You have 3 seconds. The first slot starts with your full pool. You have 5 options to choose from. For the remaining slots, your choices drop to 4 and then 3. Multiply the slots together to find the 60 possibilities. You just solved a complex permutation through logic, rather than by plugging numbers into a fraction. Here is the final challenge. Use this array of 7 unique letters, A through G, to create a 4-letter security code. No letters can be repeated. Apply the slot method and the AND rule. Calculate your final answer and leave it in the comments. Once you have that solution, you are ready to move from ordered arrangements to the world of combination. When you first learn about arrangements, textbooks hit you with this formula. It looks intimidating, and trying to memorize it is the wrong way to start solving problems. Let's ignore the algebra for a minute. Instead, look at these 3 empty slots and the 5 race cars hovering above them. We need to park 3 of these cars in specific ranked positions, first, second, and third place. For that first slot, we have exactly 5 independent choices. Any of the 5 cars can park there. Once parked, only 4 cars remain to fill the second spot. And after that, exactly 3 cars are left for the final spot. To calculate every possible way this could play out, we simply multiply those physical choices together. 5 times 4 times 3 equals 60. You just solved a complex permutation problem without using a single letter of algebra. By mapping out the physical choices slot by slot, intuitive logic does the heavy lifting for you. The hardest part of counting problems isn't the arithmetic. The real challenge is the decision-making process at the very beginning of the problem. You always have to ask yourself, does the specific sequence of these items matter? Look at the locker on the left. Code 1, 2, 3 works. 3, 2, 1 fails. Sequence dictates success. Compare that to the fruit salad. Apple or banana first, you get the exact same salad. The rule, if order matters, it's a permutation. If not, a combination. Selecting 3 of these 5 fruits using the slot method gives 5 times 4 times 3, 60 arrangements. But that assumes an apple-banana-plum salad differs from plum-apple-banana. To fix this redundancy, divide by their total arrangements, 3 factorial, or 3 times 2 times 1. Combinations are simply permutations, where we have mathematically divided out all the duplicate overlapping groups. Try applying this logic. 10 people are in a room, and everyone shakes hands exactly once. How many total handshakes happen? Run the order test. Since a handshake between person A and B is the same as B and A, order doesn't matter. It's a combination. 10 choose 2 gives us 45 unique handshakes. Once you conquer the order test, the final hurdle is handling multi-step problems, where you have to decide whether to multiply or add your independent choices. This diagram illustrates the AND rule. Picking a shirt and pants? Your choices compound. 3 shirts times 4 pants gives 12 outfits. Now the or rule. Choosing a shirt or a dress? Options remain separate. 3 shirts plus 2 dresses equals 5 choices. Let's lock this all in with a final summary matrix. On the red side, permutations, order matters, think of a locker code, and use the slot method. On the blue side, combinations, order doesn't matter, think of a fruit salad, and divide out the duplicates. And across the bottom, multiply for and, add for or. Here is your final challenge. You have 5 books on your desk, and you need to choose 3 to pack in your bag. Run the order test. Are you dealing with an arrangement or a selection? Calculate the final number and leave your answer in the comments.
Hit subscribe to simplify your syllabus. And turn on notifications so you never miss a splash.